Welcome back to study Relation and Functions Chapter 2 of Class 11th. Let us first recall what we have done in the previous episode. In the previous episode, we have studied about ordered pairs, that the two elements grouped together in a particular order is said to be an ordered pair. Cartesian product of two sets, that when we are having two non-empty sets P and Q, the Cartesian product P with Q is the set of all ordered pair, where the elements are coming from P and Q. Students, I have given you one assignment. Hope you have solved that particular question. So let us see the answer of it. This was the question in which what was given to us? Two sets A and B, non-empty sets, and common elements between these two sets. How many common? 6 elements. And what we have to find? We have to find common elements in the Cartesian product of these two sets. That is, what are the common elements between when we find the product of A with B and B with A. Okay? We have also given you a hint, and this is very helpful. So first of all, let me give you the answer of it. Answer is 36. Those who have find it as 36, yes, you are correct. So let us see how we can find this answer. We have to find the number of elements in this set, and this set is already given to you, that is, it is equal to this. So we can use our hint. Now, we already know that the number of elements in Cartesian product of any two sets is equal to the product of the number of elements in individual sets. And how many elements in the intersection? 6 elements. It is already given to us. Again, B intersection A is also same. How many elements in this? 6 elements. So, number of elements in this becomes 6 into 6, which is equal to 36. This is how we are getting this answer. 36 elements are common in these two Cartesian products when we product A with B and B with A. Hope you have understood. Now let us move further and know what we are going to cover in today's episode. In today's episode, we will going to cover concept and definition of relations, visual representation of a relation, which is an arrow diagram, introduction of some terms like image, domain, range and codomain of relation, and questions related to it. So, let us see in this. These are two sets. Let me name it as A and B. Okay? And if I ask you to find the Cartesian product of these two sets, it is easy. What you will going to do? You will going to find all ordered pairs. If now I ask you that find the subset of the Cartesian product where these two sets are related with some rule, then what it will be? Say suppose I have to find all those ordered pair x and y such that y is vowel in x where this Y is coming from the set B and X is coming from the set A. Okay? So can you tell me what ordered pair will be there in this R? What you will going to do? Math. See this first element. How many vowels are there in this word math? 1. A. So this will be the first ordered pair, math with A. Now physics. How many vowels are there in it? Again 1, which is I. In civics, again 1. So 1 ordered pair, that will be with I. English, it consists of 2 vowels, E and I. So ordered pair, English, E and English, I will be there in the set R. And Hindi, again it is related to I. Okay. So what we can say? R is having how many elements? Let us first write them out. So I am using first letter for representing each subject. M, A. Okay, let me write over here. M, A. P, I. C, I. E with E. E with I. And H with I. So this set is a subset of the Cartesian product, where each element of the ordered pair are derived with the relationship between the two elements of an ordered pair. Now, let us see the formal definition of relation. The formal definition of the relation is a relation R from a non-empty set A to a non-empty set B. Remember, we have named this set as A, this set B, and relation R from set A to B is the subset of the Cartesian product A with B, and the subset is derived by describing a relationship between the first element and the second element of each ordered pair. Notice, in the previous example what we have described, the relation R can be represented in both the forms. Which forms? Roster form as well as set builder form, as we have seen it before. Now let us take some examples on it. Before taking examples, let us understand some terminologies. In this, the first terminology is our image. Remember what we have seen? This is our relation, set A, set B. What was our relation? Y is related, that means all the elements in set B is related to the elements in the set A, where Y is representing vowels in the elements of set A. So math is related to A, physics is related to I, civics is related to I, English is related to E and I, and Hindi is related to I. Okay? Now, image. The second element is called the image of the first element. That means A is an image of math, that is the first element. E is the image of English. I is the image of how many elements? 3 elements, 4 elements. Physics, civics, English and Hindi. Okay. So, if I write, again I am writing here the relation what we are getting in the roster form. That is math and A. Say Hindi and I, and so on. So, the second element is said to be the image. Okay. Now, the next term, domain. Domain is the set of all those points, or we can say elements, in the relation R from the set A to B. That means those who are having image in the set B. And how many elements are there which are having image? In the set A, all the elements. So, math, physics, civics, English, Hindi, all elements are coming in the domain. Now, question arises, every time is every element will be there in the domain? Think upon it. We will going to discuss it later. Now, the next terminology, that is the range. Range is the set of all images. Images are A, E and I. Notice, the full set B is not a range. The full set B is said to be codomain. And the elements in it which are becoming the image of the element of the set A, the set of all those images, is known as range. Obviously, we can depict the relation between the two, range and codomain. Range is a subset of codomain. It can be full set B and it can be a proper subset of D as well. So, let us move further and see this example. In this example, a set A is given to you, in which how many elements are there? 6 elements. 1, 2, 3, 4, 5 and 6. We have to depict the relation which is given in a set builder form from A to A. Okay? So, this is my set A, this is also a set A, and we have to depict a relation R where the relationship is given by this. What we have to find? Arrow diagram. That means we have to represent our relation with the help of an arrow diagram, and the domain, range and codomain of the relation R. So, first let us represent the relation R in these two sets, which is our arrow diagram. Now, see in this case, the second element, that means the second element is twice of the first. That means the image of 1 will be 2. Okay. Now, image of 2 will be 4. And image of 3 will be 6, because they are related with this relationship. This is how they are related to each other. This representation is representing our arrow diagram. This is how we represent it. Now, in this, what we have to see? or what we have to find it out? Domain, range and codomain. Remember, I have asked you, will each and every element of the first set will always be a domain? Now, see here, it is giving me the answer for that. No, it is not necessary. What will be the domain in this relation R? Let us write it down. The domain. Quickly representing it in the form of arrow diagram. So this is what a representation of a relation. Now domain. What is the domain? How many elements are having its image in the set B? Only 3. That is 1, 2 and 3. So domain will have 3 elements and they are 1, 2 and 3. Okay. Now range. Range, the set of all images. Again, how many images are there? 2, 4 and 6. 3. So range will be 2, 4, 6. And codomain is full set B, which is 1, 2, 3, 4, 5 and 6. That is whole set A. Remember, we have represented this set B, but we know both the sets are equal. So we can replace it and show this as A. Okay. Now, observation, we have already observed that range is a subset of a codomain. What I am giving you? I will give you the visual representation and you have to find the relation of it. That means you have to find or you have to write the relation in a set builder form. Very simple. Again, these are two sets A and A. I am defining a relation R from A to A, and the arrow diagram is giving me like this. Say suppose I am not representing it like this. Say like this. Okay. Now, can you write the relation in a set builder form? By understanding this arrow diagram? Yes, you can. How? See this case. R is a set of all those ordered pair X and Y such that there is a relation between the 2 points or 2 elements. What is the relation? You may notice that the second element is what? It is plus 1 of the first element. So I can write X plus 1. Okay? Where both X and Y are coming from the set A. So we have formed a relation of all those ordered pair where the second element is a successor of the first element. Now, what will be the domain, range and codomain of this relation? Easy. Domain, two, 3, 4 and 5. 6 is not in the domain. Why it is not in the domain? Because it does not have a image in the set A. It does not have an image, so it will not be included in the domain. So 1, 2, 3, 4, 5. Range, very well, we can see in this arrow diagram 2, 4, 2, 3, 4, 5 and 6. And codomain, full set A. So this how we can say this how you can represent relation from an arrow diagram. Let us see one more example or question. This is a question in which we have to find the domain and range of the relation this. See it, very important. Firstly, we will going to see the set A. Say suppose, let us first make an arrow diagram of it. A to say suppose some B, we are describing a relation R. What is this A? X, first element, X is coming from naturals and it is less than 6. So all those natural numbers which are less than 6 will be in the set A. 1, 2, 3, 4, 5 and 6. These are the elements in set A. And in set B, all those natural numbers, but no condition is there for Y. That means it can be any natural number. Okay, so that means B is nothing but equal to the set of natural numbers 1, 2, 3 and so on. Fine. Now, the relation is Y is equal to X plus 6 by X. Let us take the first element 1. Will it be related to or whether it will have an image in the codomain? So 1 will be, if I say suppose, if I am writing as 1, let us see whether it is related to any element or not. So Y will be 1 plus 6 by 1, which comes out to be 7. And yes, 7 is a natural number. So yes, 1 is related to 7. Now the second 2, remember I have taken 6. Will 6 will be included in the set A? Hope you have seen this. No, it will not be included. So 6 will not be included in set A. Why? Because there is a strict inequality. If I'll put an equal sign there, then 6 will be there in the set A. Right now 6 will not be in the set A. See this case? Now let us take the second element. So, Y is equal to 5. So yes, 2 is also having its image. 2 is related with 5. Now let us take 3. What will be its image? 3 plus 6 by 3, which is again coming out to be 5. So 3 is again related to 5. Now let us take the second next element, which is 4, and let us see whether it has an image in the codomain or not. Y is equals to 4 plus 6 by 4. You can see that Y is not coming out to be a natural number. It is coming in fractions. And we know Y is always a natural. So 4 will not have an image. Okay? So 4 is not related to any of the element. Correct? Similarly, we are going to find it, each and every image of each and every element in the set A, and see whether it has an image in codomain B or not. So you can see in this what we get. We get domain as 1, 2 and 3. 4 and 5 will not have its image, and range is 7 and 5. So let us take another question. In this, the relation is given K, where the elements are related as, if K is a real number, then the positive value of K, that is the modulus value of X, will be its image. In this, we have to find the domain and range of this relation K. Remember, very easy. K is taking which values? All the real numbers. So what will be the domain? Obviously, every real number, for every real number we can find its positive value. So what will be the positive value for each and every real number, and it has an image. So the domain becomes the set of real numbers. Okay? And the range, what will be the range? We can see from here the set of all positive or non-negative. Think upon it. Non-negative real numbers. Why this so? Because if we take 0, the modulus value of 0 is also 0, and 0 will also be there in the range. Correct? So range becomes, we can see over here, then the range becomes 0 till infinity. Okay? And this is representing the set of all non-negative real numbers. So let us see what we have learned today. So today we have learned about what is relation. That is, a relation R from a non-empty set A to a non-empty set B is the subset of the Cartesian product A with B. Next, what is an image? The second element is called the image of the first element. This is first element. Domain, yes, the set of all those elements which have a image is known as domain, the set. Range, the set of all second elements, that means the set of all images. And lastly, an observation that how many relations we can find from a non-empty set A to a non-empty set B. Hope you have understood and enjoyed this episode by learning about concept and definition of relations, visual representation of relation, and solving questions based on it. In the next episode, we will going to study about functions. Thank you.